Hello everybody. Let's continue with exercise 9.3. So there are some 4 sums left out. So let's complete that. If the non-parallel sides of a trapezium are equal, prove that it is cyclic. That means it's inside circle. Non-parallel sides of a trapezium are equal. So let's draw a circle because they have asked you to prove. Now let me draw a little bigger one. Okay, so this is a trapezium. Okay, this is a trapezium. All right, let's name it as A, B, C, D. So given A, B, C, D is a trapezium. I'm going a little fast. Hope you understand it. A, B, C, D is a trapezium. Non-parallel sides are equal. So these are the non-parallel sides. This is the parallel side. Okay. This is the non-parallel side. Trapezium will be like this now. See, like this way. So these are non-parallel sides. So AD is equal to BCD I am given. You have to prove that ABCD is a cyclic quadrilateral. Now for this what I will do is I will make it a construction here. Draw BE parallel to AD. So now therefore prove BE is parallel to AD, B is parallel to AD and AB is parallel to DE. This is by construction, this is given, okay, construction, and this is given. Therefore ABED is a parallelogram. Okay, it's a parallelogram. Now for convenience, instead of renaming all that, what I'll name 1, 2, 3, 4, name all the angles. Now this much only I'll name and take because I want to prove opposite angles which will be related here. Here also, but here there's a construction, that's why I'm naming here. Now let's take C first. AD is equal to BE by construction, right? And AD is equal to BC given, right? Things which are equal to the same thing are equal to one another. So therefore this gets cancelled. So we'll get BE is equal to BC. Correct? BE is equal to BC. When BE is equal to BC, therefore it becomes an isosceles triangle. Angle 3 is equal to angle 4. Correct? Angle 3 is equal to angle 4. Okay? Therefore angle 3 is equal to angle, because angles opposite to equal sides. Okay? Then angle 1 is equal to angle 2. Why? Because opposite angles of a parallelogram, because I proved by construction. Opposite angles of a parallelogram are equal. Now what we do is, we'll stick here. There's no place here. Now we'll write, see, angle 2 plus 3, angle 2 plus angle 3 is equal to what? 180. Linear pair, correct? Angle 2 is equal to what? Angle 1. Angle 3 is equal to what? Angle 4. Right? Because we just now proved it here. Is equal to what? 180. See, angle 1 and angle 4. 180. They form the opposite angles, right? So, opposite angles of trapezium are is equal to 180. Therefore, ABCD is a cyclic trapezium. Okay, is a cyclic trapezium. Okay, right, made it much simpler so that you will understand it. Okay, first take AD is equal to BE, then take AD is equal to BC, then they'll get cancelled, we'll get these two equal. Then you'll say angle 3 is equal to angle 4, then you'll say angle 1 is equal to angle 2, opposite angles are parallel. Then take linear pair, 2 plus 3 is 180. Instead of 2 write 1, instead of 3 write 4. 1 plus 4 is 180. That means opposite angles of a cyclic quadrilateral are 180. Now this one, here it's mentioned that two circles intersect. Circles intersect at B and C. B and C. Okay. And through line segments ABD and PBQ, the two line segments, you have to prove that angle ACP, this angle is equal to QCD. QCD, this angle, okay, is equal to angle QCD. Now what we do is, see, I told you always when there is a circle, look out for some like this, right? Now what we do is, this angle 1, this angle I'll name it as 2, 3 and 4, something round about here only, because to prove is here, okay. So see, angle 1 is equal to angle 2. Why? Angles in the, yes, perfectly, angles in the, you're correct, same segment, correct. I told you to look out for M, angles in the same segment, okay. Now angle 3 is equal to angle 4, angle 3 is equal to angle 4, that is also angles in the same segment, because this is the chord, correct. See, here this is the common chord and here this is the chord, correct. Angle 3 is equal to angle 4, the same reason. Now but angle 1 is equal to angle 3, angle 1 is equal to angle 3, vertically opposite angles, see here, vertically opposite, therefore angle 2 is equal to angle 4, correct. See, 1 2 3 4, 1 is equal to 3, therefore 2 is equal to 4. Now which is that angle 2? PCA, right, or ACP, correct. Angle ACP is equal to angle DCQ, because 4 is this one, QCD. That's it, proved. Understood? First you'll write 1 is equal to 2, angles in the same segment with chord AP. 3 is equal to 4, angles in the same segment, chord DQ. But angle 1 is equal to angle 3, therefore angle 2 is equal to angle 4. Next, if circles are taking two sides of triangles as diameters, prove that the point of intersection of these circles lie on the third side. So let's draw two circles, 1 and 2. Okay, this is the common chord. Circles are taking two sides of a triangle as the diameter. So this is one side of the triangle, this is another side of the triangle, and they form the diameters. Let's name it as A, B, D, C. Okay, so you have to prove that the point of intersection, that is D, of these two circles lies on the third side. That means to prove that D lies on BC. Okay, D lies on BC. Let's make the proof now. Simple. AB is the diameter, correct. Therefore angle ADB becomes how much? When diameter comes in a circle, use that angle in a semicircle, correct. This is 90. Then similarly this side, AC is the diameter. They have mentioned already in the question. When AC is the diameter, what do you say of angle ADC? Angle ADC is also equal to 90 degrees. Angle in a semicircle, this is also 90, correct. Now if I add these two, therefore angle ADB plus angle ADC is equal to how many degrees? 180 degrees, correct, right. Therefore BDC is a straight line, correct. 180 means straight line. Therefore D lies on BC, because this is a straight line. D lies on BC. Finished. Understood? This is diameter, this is 90. This is diameter, this is 90. Angle in a semicircle. Together you add, you will get 180. That means BDC is a straight line. BDC is a straight line means D lies on BC. Next, triangle ABC and triangle ABC and triangle ADC, they are two right angle triangles, means this is 90, this is 90. You have, and hypotenuse is, so angle ABC is equal to 90 degrees. Angle ADC is also equal to 90 degrees. Two right angle triangles. And hypotenuse is AC. AC is the hypotenuse. Okay. You have to prove that. What you have to prove? This is what you have to prove. Angle CAD, this angle, CBD. So I'll draw a line here. This angle. These both angles are equal. You have to prove. The ones where I put dot. CAD, CBD. See, this becomes like this. See, M, right? That means you have to prove this is a cyclic quadrilateral, right? For that, what we'll do? Very simple. See, now AC is the hypotenuse, right? AB, angle ABC is equal to how many degrees? 90 degrees, right? When ABC is equal to 90 degrees, then what does angle ABC become? Angle ABC is an angle in a semicircle. Okay, angle in a semicircle. Similarly, angle ADC is also equal to 90 degrees. Therefore, it also becomes angle in a semicircle. Is angle in a semicircle. Now, when it is a semicircle, that means what? AC and BD are the diameters. AC and BD are the diameters. Okay, when they are diameters, that means ABCD, angle B plus angle D is equal to how many degrees? Angle B, see, this is 90, this is 90. This plus this is how much? Angle B plus angle D is equal to how many degrees? 180 degrees. So when this is 180 degrees, ABCD is what? A cyclic quadrilateral, correct? Opposite angles are supplementary, correct? I'll write it here. So ABCD is a cyclic quadrilateral. Now when ABCD is a cyclic quadrilateral, what do you say of these two angles? Therefore, angle DAC is equal to angle DBC or CAD. I'll take as it is given in the question. CAD is equal to CBD. Angle CAD is equal to angle CBD because they are angles in the same segment with chord. Which is the chord here? DC is the chord. Hope it's clear. Simple. See, this is right angle, no? This is 90 degrees. This is 90. So this plus this is 180. Therefore, this becomes a cyclic quadrilateral. Therefore, this angle is equal to this angle. Angles in the same segment with DC as the chord. See, DAC, DBC. That's it. Finished. Bye, children. Take care. Thank you.